fixes. So we have side effects and functional purity. I know somebody will see side effect and be like, are we back in, what's it called? Medicine, like selling medicine or something? And functional purity, what does that mean? Are we back in chemistry class? No. So now to finish up this section, this functional advanced function section, I want to teach you the most important thing that you can do as a web developer. And you can do this when you are writing your code. And that is the idea of avoiding side effects and, you know, avoiding impure functions. So what does that mean? Well, if we go back into my slide here, that we have here, you know, oops. So let's go back to this diagram. You might remember this from the first section when we started our training, where I said that an input is what we give a function. You know, we have this 5 and 10 here. These are inputs. And if you remember, I think when we were in primary school, they used to tell us, well, what is a computer? The basic definition they gave us then is a computer is a machine that accepts inputs, processes or accepts data, processes data to give back information. Or probably a computer is anything that accepts input, processes the input, and gives output. So basically, that is what a computer is. And we are programmers. And what are we doing? We are programming the computer. So how do we program a computer? We write instructions that a computer is going to understand, translate, and give us a desired result. So that is why we are a programmer. Anybody can use a computer. They don't care what is happening behind the hood. But as a programmer, you should be able to like, okay, I want to do something that people will be using. So I want them to be using this particular machine. So how do you make the machine work? You write instructions, and that is what we are doing with code. So if we check our code, everything we've been writing are instructions. Everything we've been writing, we call them instructions. So all this we are writing ever since, they are instructions. So it's just like you are instructing, like, you know what, my computer, do this, after this, do this. So the computer is going to understand, like, okay, you want me to do this. So they are instructions. So back to this, you know. So an input is what we give to a function. It could be an empty input. Probably you don't have any parameters there. Or it could have parameters like 5 and 10. A function does something that we defined. It has its own scope. So it has its own local scope. It has its own universe, like I said the other time. So it could have console.log to print something out. It could do some, a bunch of stuff. And then it asks, like, you want me to do something? Am I returning anything back to you? So you can return a value, or if it does, like, if you actually don't want the function to return anything, any value, it gives undefined back. So what are side effects and functional purity? Well, side effects are any action that happened inside of a function. Like we have this function. Any action that happened inside of a function that we don't really know anything about. So if a function interacts or reads or writes to an external variable, for example, or it console logs something out, well, that is a side effect. That means the function is not pure. It is not pure at all. It is impure function. So you get to see this a lot. Like people talk about that a lot when it comes to programming. I need to like adjust this screen. Okay. So, an observable side effect is any interaction with the outside world from within a function. That could be anything from changing a variable that exists outside that function. probably to calling another method from within another function. So if we do something like this, so that we can understand what I'm actually trying to like explain. So if we do something like this, like we can use our old friend var. So if you do something like this, var equals 1, and we have a function that changes that a function b, you know, the name of this function is b, and we are setting a to be equals to 2. Yeah. So if we do this, this has a side effect. You know, that is something that, you know, a function is doing to affect the outside world. So this function is actually changing what is here. So this is a side effect. This is an impure function. We want a function that, you know, that is pure. So what do we mean by pure function? Don't worry, I will explain that. So, and remember something like, we want to think of a function as, you know, its own universe, and we don't want it to affect anything outside this universe. So I mean, actually, you can do it this way. It's not the end of the world. You know, we've done a lot of impure functions before, whereby we have to do something like this. So you console.logging something out from a function makes it impure function. So we've been doing this a lot, and this is an impure function. So, but it is a good practice to avoid the side effects by avoiding the side effects. So the only way to avoid something is just to avoid it. What is bad is bad. So we have something called functional purity. So if you go back to my slide. So what is functional purity? Yeah. So what is a pure function? The definition of a pure function is the function always returns the same result if the same arguments are passed in. It does not depend on any state or any data. You know, it does not depend on any change during program's execution. It must only depend on its input arguments. So the second definition is the function does not produce any observable side effects, such as network requests, such as, you know, input and output devices, or data mutation. If you remember, we talked about data mutability and immutability when we are talking about array methods and the likes. Like some array methods can render the whatever value, whatever data you have, they can change it, and that is not what we want. Like if you are using something like what's it called, push, pop, and the likes, and you remember we use another method which is concat, which does not mutate, does not change. What it does is it creates a copy, then, you know, manipulate the copy it created without touching the original data. So, and it is one thing you want to do, like as a programmer. So functional purity is a concept where we say, in order for us to write really, really good programs, we want to avoid side effects, and we always want to return a value so that we don't have undefined. We don't return undefined. And what is the power in this? Why should we write pure functions? By avoiding side effects and always returning something, we create something that we called deterministic. So we create something that we call, let me write it out, deterministic. And deterministic is a word that you may have heard before. It means that no matter what my inputs are, the return value must always be the same. Even if I run the program 1 million times, it must return the same thing back to me. That's 1 million times. 1 million times. So if I give my program 1, it should return 1 back to me. Not that I give my program 1 now, then it returns 1. Then after running the program for like the 100 times, it returning 2 back to me. No, that is impure. So your function must always return the same value every time you run your program. So let's do some examples. Let's say we let's say we want to like write a function to get a square. So we can do like this function should, let's say x. It receives x and it multiply x by x and return the value back to us. X by x. So if we run this program in the console, we should get the same result back 1,000,000 times if we run it. So for example, so if I do get squared, what is the square of? Sorry, my square is wrong. Let me write that. Oops, bring down. You don't have to square square. So let's say I want to get the square of a number. So if I do, let me delete this. So if I do this, so if I do get squared, what is the square of 5? Let's do, okay, 5. So this should return 25 back. So if I run this 1,000,000 times, I should get 25 back 1,000,000 times. Because it's saying like receive 5, then 5 times 5 give me 25. So that is what this is saying. This is pure. This is a pure function. Or probably I'm saying multiply function receives a and b and should return the multiplication of a and b back. So if I do this, let me clear this. If I do multiply 3 by 4, I get 5 and 12 back. So if I run this 1,000,000 times, I'm getting the same result back. So this is a pure function, and that is determinism. It is deterministic. Like I can determine what I'm getting back. So it is a very important concept, and that's a key principle in avoiding bugs. Because if this function always does the same thing, then you know exactly what it does. You know exactly what you are getting back. You have random errors, and you have a lot of bugs popping up here and there. So that is what I want to, leave you with. Although this is not the law, and you find code bases that will have a lot of side effects. There's going to be a lot of things happening inside a function that maybe even have, affect variables that live outside of a function. It is really, really good practice to be a top performing developer to have this in mind, that you should always create functions that minimizes side effects and have functional purity. And that is what we call determinism. You have to write code that are deterministic, where anything you put into the function, it always returns the same thing. So in summary, pure functions always return the same result if the same arguments are passed in, like we did here. So if the same arguments are passed in, pure functions always return the same results. It does not depend on any state. It does not depend on any data. It does not change during program's execution. And it must only depend on its input arguments. They do not have any side effects and do not modify the arguments which are passed to them. So another example that I can give us before we go is, let's write a function that calculates the price of a product, including the tax. So if I do const price after taxation or after tax, so this receives the product price, then it returns. So I'm setting this explicitly. It returns product price multiply by 0.2 plus, actually, I think this is how they calculate. I don't know the the tax rates, but I'm just using this as an example. So as you can see here, this particular function doesn't depend on any external input. It doesn't mutate any data outside of it, and it doesn't have any side effects. So what we are doing here is we are just receiving a product price, and we are multiplying the product price by a fixed value, then adding it back to the product price. So if we run this 1 million times, we should get the same result back without any funny um, behavior. So if I do this and I pass it, if I pass it like the product price is 30, so I'm paying 36 naira plus the tax. So if I run this 1 million times, I'm getting the result back. 1 million times, I'm getting the same result back. So what is an impure function? An impure function is any function that changes the internal state of one of its arguments or the value of some external variable. They may have any side, effects, and may modify the arguments which are passed to them. So for example, if we run another function, so let me just write here, let's do pure functions, and here let's say impure function or function impurity. So impure function. So if I do, let's say we do let task equals 20, and let's write a function that calculates tax. So it's going to receive the product price. It's going to receive the product price, and it's going to return product price multiplied by tax divided by 100 plus product price. So if you pause for a moment, and you try to like guess why this is an impure function, I'm very sure you come up with, with something. So if you think it's because that this function depends on an external tax variable, you are right. So a pure function cannot depend on outside variables. So it fails one of the requirements of a pure function. So, and sometimes if you do like a for loop, like we did a while ago, like let's count, we have, if we say let's count equals 0, and we do for let I equals 0, I is less than 5, I plus plus, and we do for every time this loop happens, count plus plus. So we can just make count 1. This is an impure, what's it called? This is impure. If you have this in your code like this and it's changing something outside, it is impure. So that is that for now. And we have a lot of exercises to do throughout the week. At least we have, how many days? We have 7 days till the next training.